Okay, it looks like we're live. So welcome. Today I'm going to be exploring OCaml and just functional programming in general. Functional programming is not something I've ever really done, and I don't really understand what it is exactly. So that's what I hope to kind of figure out today. So the Wikipedia page, flashbang by the way. Functional programming, right? It's a programming paradigm. I know that. Constructed by applying and composing functions. Yeah. So the way I understand it is basically functions are they're I don't know how to explain that because I don't understand it, but it looks like kind of nerd stuff, like calculus and stuff. Uh, so maybe it'll be interesting. Yeah, there's stuff in all these, yeah, but like actual functional programming, like C++ isn't really a functional programming language. Yo, hey there, how you doing? But yeah, so I'm using OCaml today, which is one of the more popular ones. It's been around for a while though. It's just recently gained a lot of popularity. But there's also like Elixir, that one's pretty popular. F Sharp, Clojure. A lot of these have been around for a while. I'm doing pretty good. Doing pretty good. Yeah, Haskell, of course Haskell. Yeah, but OCaml, that's what we're doing. I've been looking into it. And it seems like pretty cool actually. Like it has a lot of tooling and stuff. That seems pretty nice. But yeah, so I just got this like learn X and Y minutes OCaml, right? So I'm gonna be kind of going through that. I was looking at it a little, not too much. Yeah, so this is just like a hello world. We can compile this. Why do we need functional programming in the first place? I don't know exactly. I understand like the benefits to like object-oriented programming, especially if you're doing like game development or something. But I don't understand the need for functional programming, like you're saying, right now, because I don't really know anything about it. So hopefully I'm going to figure that out today. Like as I program it, I'll see sort of what the benefits are. But yeah, so compiling this, you can just do OCaml C, and then the name of the file, and it's compiled. And there we go, hello world. So that's pretty cool. Yeah, we can modify this, make sure it is working. Whoops. Yeah. Alright, so that's all working. And it's actually really cool the way it works. If you look at it, it's not a native executable. It's bytecode, OCaml bytecode, and that's pretty cool. But it can also be compiled using like I forget what it is, something like that. Yeah, yeah. Then you can compile it, and then now it is actual bytecode or actual executable. I tried once with Haskell, and to be honest, I got so much confused. Yeah, looking at the syntax, like this stuff, it looks pretty confusing. And same with Haskell, yeah. Because it's just a different way of thinking about things. So it's confusing when you're used to languages like C and stuff. Yeah. I can just remove all these files, I don't need them. Alright, there we go. Yeah, so I'm gonna be looking into this a little. It's like we can declare this is a variable, so but it's also a function, right? And this is just where you can pass the parameters and stuff. But you can also just do like let x equal 10. You put 2 semicolons at the end. I don't know what the deal with that is exactly, but that's how it works. But yeah, so that's pretty straightforward. But then yeah, it also has this, which is pretty cool. It's like to make like a temporary variable and stuff. I can see the use in that. Yeah, and then like recursive functions, you have to specify recursive. That's pretty standard. Yeah. So let's just kind of try it out. We don't need that. Let's see. So I'm just gonna be copying this, and then I'll modify it a little and see if I can figure out how it works. Hit 1. Yeah. Else. Alright, yeah, and then I think we can do something like factorial 5 equals factorial 5, and this could be any number. So if I actually OCaml C hello.ml, no return. Yeah, I was looking at that. There is no, so I think it's just like return. Like, it's just, I don't understand how it works exactly. But yeah, so I was also looking, you can do something like, should I forget what it is? Printf in OCaml. You have to include format or whatever. I forget how to do it. Let's see. Print int in OCaml. Let's see. I forget what it is exactly. Let me see if I can find it. Yeah, format. This is what I want. I just forget how to include it. Let's see. Oh yeah, open. That's what it is. That's the key. Open format, and then you can use printf. So then we could do something like let that equal printf, and then there we go, and fact 5. Like that. So then, yeah, there we go. 120. And that is 5 factorial, I think. Let me just make sure. I don't know it off the top of my head. Yeah, 120. Alright. So that's pretty cool. And you can change this to whatever. Factorial of 10. That'll be pretty big, actually. Yeah. Oh, shoot. Yeah. Alright, and you can also provide a new line. I forgot that you gotta do that. Alright, so that's making sense. And then 1, if it's 0, then it should just return 1. Yeah, alright, so return 1. You can use print in. Oh, print in? Oh, okay. It doesn't print the new line though. Let me see. Print int. Okay. Alright. Well, yeah. Either way, it doesn't really matter. Alright, so let's look at this function. So, basically, yeah, it makes sense. Makes sense. So, if... Alright, let's try to write another one. Let's see. They have some challenges here. I'm not sure. So, this takes in a list. I'm not sure how to work with lists exactly. Let's keep going through this a little. Yeah, square root. Alright, and you don't need to put parentheses around it. Print new line, okay. Alright, there we go. Yeah, so couldn't do it this way or the printf way. It doesn't matter. Printf way is familiar. Alright, yeah. So this is the print end line, yeah. You must specify that as the argument when calling it. Okay. Calling a function with an insufficient number of arguments does not cause an error. It produces a new function. What? Huh. Not quite sure I understand that exactly. Let's see. Let's try that next. So, I have to go above tomorrow, and this time I'm gonna stream. Okay. Pretty cool. I will try to catch that. See you later. It's probably night for you, or pretty late, so good night. Okay. Yeah, so let's see if I can do something like this. So if we add n and x, and let's see, we can just rename this too. Fun, no, that's a keyword. Z. That works. I think that'll work. Alright, and then it takes n plus x. Let's call this. So let 0 equal z5 12. Alright, let's see that. 17. Okay. Yeah, so that works. Then if we do that, okay, so then it's a function. Yeah. That x0 equal test 5. Alright. Okay. That's pretty interesting, actually. Alright, so then I see how that's working, I think. Yeah, so that'll be 22. Yeah, that's interesting. That is an interesting way of doing things. Let's see. In multiple expressions in the function body, this expression becomes the return value. All other expressions must be of unit type. Okay, is a functional language that lacks procedures. Every function must return something. So functions that do not really return anything are called solely for their side effects, like print inline, return the value of unit type. Okay, let's see. Can be chained. Alright, let me try that out. X equal 10 in 1 equal 20 in x plus y. Alright, I gotta do a new one. Alright, let's see. So what the no. Let's see. Wait, it's equal because of that. Character is 11 to 13. Let me rewrite this. Not sure why that doesn't work exactly. Quite interesting. Why doesn't that work? It says it'll work here. Alright, let's get rid of all that. Alright, let recursive is even this function. Alright, you can just use the let and in construct. It's especially useful for mutually recursive functions with ordinary let in. Compiler will complain about unbound values. Alright, so what does this mean? True is odd and minus 1, and is odd equals function, 0 is false, and is even and minus 1. Okay, so now let's print it out. And equal print, we'll use print out. Is even to, actually that's not gonna be, even equal is even 2. True. Okay, and if we change this to 5, false. Okay. Okay, I'm starting to see how it comes about. Anonymous functions use the following syntax. Okay. Alright. That's like a lambda. Makes sense, makes sense. Okay, so operators are functions, basically. Floating point addition. Okay. Alright, that makes sense. Change that. Alright. Yeah. But then if we do point .0, gotta change this to, let's see. Oops. Oh, okay, you have to put the dot in the... Okay. Alright, I see. So, you don't need this then, right? Just is implied? No. Okay, so it does need the dot. Okay, I see. Mm-hmm. Pure integer, okay. Alright, list. Closed, alright, and yeah. That's how they're separated. I have seen this. Let's make this just x. Okay, so let x equal 1, 2, 3. That's how they're separated. I think it's gonna print. Yeah. Can you print all this? Yeah. So how do for loops work? Let's see. For I in x. Let's see. Let's see if this will work like that. No. Yeah. Let's see. Alright, so then printf, do list dot in x, so the 0 way. Let's see, that doesn't work. Alright, let y equal list dot in. Okay, it has to be list, right? Okay, alright, let y equal list dot in x0. Let's see if I can do that now. Okay, we can change it. Let's see, what if we go out of bounds? Yeah, that doesn't work. Yeah, that also doesn't work. Okay, that is making sense. So that's how we can get each one. Arrays. Oh, okay. So that's how they define arrays. So that's alright. Let's try that actually. Let's make this an array, just like that. Then this can be x dot 0. That should be 1. Yes, sir. All right, that makes sense. Making sense. Double quotes for string literals. Single quotes for character literals. All right, that's fair. That's fair. Single and double quotes are not interchangeable. Yes. All right, that makes sense. That makes sense. Now, like Python. This will give you a single character string, not a character. All right, that makes sense to me. Strings can be concatenated. Oh, okay. I like that. I like that. So if we have like let stir1 equal hello space, and then let stir2 equal world, and let stir3 equal stir1 stir2, and then if we print f stir3, so it's working. Hello world. Okay, forgot the new line, but yeah. Alright, so that is pretty cool, pretty simple. Strings are not arrays of characters. Okay, you can't mix characters and strings in expressions. You can convert a character to a string with a string dot make. Okay, okay. I like that, I like that. There is a printf function. Oh, okay, so you can actually, you can use it just like this. Okay, that's a bit simpler. Yes, alright, and can you format printf as well? Yeah, okay, okay. I guess the supported way though is more like that, and then we can just do that. Okay, that makes sense, that makes sense. 99 bottles of beer. There's also unformatted read and write. Yep, okay. Print string, print end line. You know, find data types. My int equals int. More interesting types also include type constructors. Okay. Okay. Let's see. Type constructors don't need to be empty. Alright. Let's get rid of some of this. Let's see. Okay, can also be used to implement polymorphic arithmetics. Types can be, alright. Alright, let is 0x equal h x with 0 is true. Otherwise, anything else, so that's false. Okay. Yes. So let's do let y equal is 0, 15. So let's try that and let's print out y. Alright, expression is type bool. Yes, I forget that. Wait, does it work with that? No. Yeah, so do that. False. Okay, and if we change this to 0. Alright, so I think we can expand this as well. So then 1 is true. So let's see. So obviously that doesn't make sense, but no. Alright, yes. So this is just like a switch statement. You can use the function keyword. Okay. Oh, okay. So you can do the same thing, but with equals function, and that should be okay. So you don't need that. Okay. So that's just like implied to be. Alright. Alright. Let's see. So if we do X isn't here anymore, so let's see, kind of like that more. doesn't work. So how do you compare them? Does it need the white space? No. Okay. Oh, okay. X. Okay. X when x is less than 0, negative x. Okay. So when x is greater than 0, return false. Otherwise, return true. So then with positive numbers, that should be basically the same thing, right? If we change that to 0, it should be, oops, true. All right, and also if we make it negative 0. All right, that doesn't work. So it has to be an integer. All right, so that doesn't work. Okay, but yeah. So yes. Okay, so that's starting to make sense to me, the syntax of it. Ooh, okay. If you wrap it like that, you can do negative. Okay. Alright. Type constructors. Type animal equals dog of string, cat of string. Say Fluffy says meow. Okay. Okay. Some list. Alright, yeah, let me actually do that. I wanted to work with lists. So let's do let recursive sum list. Let's see, so what does that do? Oh, that is just, yeah, let's make this x with no. Oh yeah, so this is empty list 0, head tail head plus sum list tail. Okay, let y equal sum list 1, 2, 3. Alright, expression is type int, type bool. Alright, 6. Okay, that is correct. So so this head, it can't just be something like H, right? It has to be head. No, so it works like that. So, right. So this is just saying head. So this is the second element of the list, perhaps? Seems to be what it is. So then this can just be T as well. And sum list T. Yeah, okay, so that still works. Okay. Okay. Yeah, so let's see this. So write a function last that returns the last element of a list. So we would do something similar to this. So if it is empty, then return none. Let's see, so then otherwise, head, tail, let's see, so how do you, let's see, OCaml check length of list. List dot length. No. Let's see. List dot length x. Alright, will match this dot length x 0 1. Let's see, this dot, how do you get the index again? What was that? Yeah, list dot in x 0. Otherwise, sum list let's see what a pattern was expected. Yeah, okay. Greater than 0. Greater than 1. Actually, just otherwise. How do we do otherwise again? That's it. There you go. So how do we get? Well, let's see what that does. Int. Alright, I think that's not the right way of going about x. Let's see. So we're gonna do like head, tail. What is head, tail, in OCaml? Let me read some more about that. Let's see. Alright, let's see. I don't like that. A option? It's not really sum list anymore, so I guess that's kind of misleading, but alright, let's look at the solution. Let's see. Alright, so it's recursive last. Okay. Yeah. And we'll return some egg. That's T. Alright, so we don't use this value, so we don't need it. Oh yeah, so that's not gonna print anything. Cool. In option. let's see what there is. Let's see. Print in option. None or some X, either manually using pattern matching on the result or using option.enter. Yeah. Okay. So let's see. So it could return none. If y none. Let's see. If statement. Let me look at that again. If y equals none, then none, else. Alright, yeah, this needs to be in like a function. 10 equal that. Alright, oops. There we go. Alright, expression as type in option. OCaml print handle in option. Alright, I want to be able to output it, so print in option. Let's see. Doesn't have anything for that. No. Manually, let's see, option dot header. Okay. Let's see what there is for that. Introduction to OCaml. Option. No. Alright. I want option dot header. Search. How do I search? No results. Has a result for that. PP print. Let's see. PP print. Let me see. PP print option. Option. Wow. Alright, let's see. Yeah, it's format. Let me do this. Let's do let recursive sum with x equal match x with that is none. That is sum x. That is t. Sum is t. Dang. Sum of x equal x with that none. That is sum x. That is sum is t. Okay. Is that okay? Then if we do, let's see, sum list 1, 2, 3. Int option. Alright, 3, okay. Let's try sum list A, C, Z, and let's see what that does. Sum Z. Alright, so that works. That works. So now let's try to modify it to get the last 2 elements. So I think we can do, let's see, does it work like that? And then we can return like a x, sum y. Let's see. I don't know how to get out of this. Alright, let me just close this. There we go. Got it. Okay. Let's do OCaml C hello.nl. Alright. Let's see. There's no constructor. Okay. Let's see. So how would we do this? Perhaps this. Let's see. Expression is type A option, but type string. Let's see. Okay, I'm gonna check list elements. Specs 2 arguments. Okay, let's see. Alright, so that's not gonna work, but we could do like A option. Let's see. There is no constructor. Okay. Let's see. What can we do here? List, view list. Match list with okay. So how would that work? No. So I know how to check that. Alright, and if there's one. Alright, so if it's that, it's that, then it's none. Okay, let's see. Let's look at the solution. So that's why. Okay. Alright, so this is using or that. Okay, so was that? I got really close to that. Expression has type int. Alright, yeah, so that print doesn't work. Okay. 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 So let's see. Nth element of a list. So we're taking two arguments. Just do list and x. List. In. So if it is x, then return that. Return this dot in. Otherwise, or if it's none, then return none. Yeah. List dot in list. List x. This needs to be capital L. Not be a list literal. Expected P is okay. All right. Perhaps we don't do that. All right. Okay, let me see. Alright, so this is actually just showing it. Dang. Alright, so that's kind of... Is there stuff that is not list? Let's see. Palindrome. Okay, that could be interesting. So, if we reverse it, is it the same? So, how would we do that? Well, so we could reconstruct it. Let's see. Append to start of list. Okay. Let's see if we can figure that out. Let's see. Palin x and match x with. Okay. How do you use the reverse function or list.read. Alright, so it's actually really easy. List.read x. Okay. Yeah. Eliminate duplicates. Okay. Dupe. Let's see. Let's see. So if it is none, we can return none. If there's only one, then we can return none as well. OCaml remove from list. Let's see how to do that. Let's see. Let's see. OCaml remove element from list. Okay, then we'll do some like head, tail, and then if head equals tail, then equals tail. Let's see, what's the syntax? If statement. Then dupe tail else dupe tail. Yeah. Intro level OCaml project. Let's see. These are, I don't understand the syntax entirely, so I need to learn it first. Let's see. Okay. Let's just functional programming problems. Let's see. Solve me first. Alright, let's see. I don't want to do this. Let me pretty sure I have an account. Let me see. Okay, we're in. Let's see, I'm gonna use OCaml. Okay. So this is an introductory challenge. Okay, input format. You're given two integers. Output an integer that denotes a plus b. Okay. So we can just do let int x equal, or x, xy equal x plus y. Can I use vim? Vim, yes. Run code. Did it work? Oh, hey, this should be reading. My bad, my bad. Reading. There, now let's try it. What in the world does the website not work? I don't understand what's going on. This, I can't even scroll anymore. I didn't get to see what it said. It wasn't right though. So what is the... How do I see? Okay. Now we can see it a little better. This expression is type unit, but x plus y. Type unit? I don't understand what that means. Okay. Let me see. So I don't understand how it's supposed to go. I don't understand what this means. Code work. Let's see. Do they have like hang on. Give me a moment. Let's see. I'm just trying to find a good resource for this. Let's see. I think I can sign in. Okay. Yeah. Do they have OCaml? Whoops. Python, choose language. OCaml. What in the world just happened? OCaml. Yes. Okay. Let's try this. I just want to do OCaml. Yeah. Where is OCaml? Did I not save it? I don't want Python. Save it. There we go. Yes. Okay, OCaml. There we go. I want a simple one. Okay, let's see. Can we find one that is a bit simpler? Like yeah, like this one. Sum of positive. Okay. So go through the whole list. Alright. Yes. Train. Let's see. Write some. Alright, so let's do. Whoops, I didn't mean to close out of that. Whoops. Vim, can I? Yes, Vim. Vim in. Okay. So X width. Okay. Let's see. Sort by easiest. Okay. Twice as old. Okay. Calculate how many years ago the father was twice as old as his son. Okay. Wait, so what is the, this is the expected output, or? Let's see. Alright, so we just need to basically double that and then subtract. So let's see. Son let's see, down. It is son divided by 2. Then return dad. Otherwise, we can do was as old. Dad minus 1. Unmatched. Okay. Syntax error. X and Y. Syntax error. Yeah. So why is that an error? If dad y by 2 equals dad, then dot else that. Let's see. Alright, where is the if statement again? N equals 1. If n equals, let's see, can I just wrap that up then? Oh yeah, I need to get rid of that. Oh yeah, because this is x now. This functional application is partial, maybe some arguments are missing. Divided 22, we got 3. Alright, so why would it get 3? Y divided by 2. No, it's times 2, not divided by. Okay, 20. Oh, okay, so that is. Okay. So, yeah, we need to keep trying this a different way. Let's see. Yeah, so let's think about how we're doing it. So we have 36 and 7. So to get to 22, then we could, that's not right, 14 from, then x minus let's see. Y times 2. So how does that work? Because that's not right. So, oh, okay, because it, okay, so not sure how to do this. So let's try that again. Let me look at. No, that's not right. Forgot that. Alright, so then OCaml get absolute value. See, I have this here. So let's see, so this will be, we can just copy this in there. Put that, and then we can just do okay. So that works. I'm not sure that that's the right way to do it. We can look at some of the other solutions and see. Oh, so alright, so I guess that is. So is absolute a built-in thing there? Okay, let's see, next one. That one's gonna be too hard. Here, let's see, there's some more in here. Whoops. Alright, let's see. Expressions matter. train. Let's see. Given 3 integers, return the largest number obtained after inserting that. Oh shoot, that one seems kind of hard. I don't want to do that one. Let's try a different one. Century from year. Okay. So yeah, just take the first 2, basically, and then, well, if you divide it by 100, and then subtract 1, right? Basically, kinda. Well, let's see. Year minus year divided by 100 minus 1. So that should be close, right? Oh wait, no, plus 1, right? So, yeah, but it's in, so it's not gonna work. Yes, that's not right. So let's see. So we can do something like let x equal year divided by 100 and match x with 0, then return, let's see, then just return x. Otherwise, return x plus 1. No, that's not right. Let's see, we can get rid of these. Now I think we can do this though, right? No. So why does you divided by 100. Yeah, that's not what I want. See, and we can wrap this in parentheses. Yeah, so it's not gonna be 0 actually. So what is? Let's see. Not quite sure. So what is? So that'd be 19. Yeah, that makes things more complicated the way it is doing that. Alright, let's see. So year divided by, so like 1900 divided by 19 is 100. So if it's 100, yeah, because we're not doing floats. So it's always going to do that. Convert int to float. Okay. Can we do that? Float of int. Float of int year. Float of no. Float of int year. That 100.0. Okay. 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 So if we do the float, then it'd be 1705 divided by 100. No. Yeah, so then we want to get the float value. Times 1705. No. I mean, wait, hang on. How does this work? Divided by 75 divided by, yeah, 100. No, but I don't want it to be 100. Shoot. So that's always gonna be 100. So that's not the right way. But if we just do this, that should be 0. It'll run. Oh, shoot. Okay. So that's that. Shoot. Yeah. So that is not what we want. What if we do this, and times 100, and we don't do the float? If it equals the year, let's see, I think we actually want this the other way. No, let's try that. Okay, yeah, that's not right. What do I... check if hold, because if we convert it to a float, int as float, yeah, that's what it was, a float of int, yeah. So that's not right. How do you do that? Just do let x equal u divided by 100. Okay, okay. Whoops, 0, then 100, else u divided by 100 plus 1. Okay, there we go. Got it. Alright, that took a minute. Let's see, more tests. Cat use dog. Whoops, where'd it go? Cat use, and it's gone entirely. Okay. Nth even number. Find multiples of a number. 2, 4, 6. Okay, so this is okay. So it takes a list. So we have to go through the list. I don't like the arrays list stuff. Yeah. I want to get familiar without that. It's another one. Strings. Alright, so we need to check if there's a space. So how do we go through a string like that? OCaml iterate through string. Zero to string length of string name. That's what we do for name. -1 do. If name I equals that, a white space, then I'm going to take name I plus 1. And yeah, we want to return name 0, name I plus 1. Where is that? I don't know where that is. Right, so that's not right. Oh, okay, wait till you're done. Alright, where is string length defined? Length of string, okay. Let's see. String dot length. Okay, let's try that. String dot length name. Not quite sure how to do this. I don't know, this functional programming thing, it's just so hard to wrap my head around, you know? You know what I'm saying? Right, repeat. String dot length of s minus 1. Actually, we can do if n equals 0, then s, else do string repeat s, maybe wrap that in this s, and then n minus 1. So it has to be recursive. I thought that was how you do it. String.concat. X equal S. And do that. Yeah, it doesn't like that. Let X equal S. Spell it right? X and n minus 4. Alright, so that doesn't work. How do we make it? It doesn't like that. I don't know. Yeah. Oh shoot. Wait, no. That should still work. Let's look this error code up. Let's use OCaml. Okay, that's probably gonna have to be it for today. Thanks for watching, and I'll see you next time.